Hello everyone and welcome to Blueprint 101. This will probably be the first lecture that you're going through. So for part of this course, we'll be working from the Precision Machining Technology book. If you hear me refer to the machining book, this is the one that I'm referring to. You can borrow from the curriculum room if you do not have yours yet, so forth. So we're going to start out Section 2, Unit 2. We're going to go over some measurement systems, machine tool, basically math overview. Now again, this is not a math course. We're not doing, I'm not a math professor. We're not going to be doing a ton of algebraic equations, but math is very important and it's prominent in the everyday skills that we do within machining, welding, manufacturing, industrial maintenance, and so forth. So what we're trying to do here is get you thinking the right way. We're going to talk about the basic fractions, addition, subtraction, multiplication, and so forth, how to measure, breaking down a tape measure, ruler, so forth. Moving forward with that, if you have any questions, please contact us and ask us individually. There are some worksheets that you're going to be using as well to kind of help you through this process of getting your math fairly rounded out as well. Thank you. So we're going to start out Section 2, Unit 2, which begins on page 65. I'm going to start out reading from the book a couple things here, and then we'll walk through the book and the PowerPoint at the same time. Okay? Page 65, left-hand column underneath the title, Introduction. I'm going to read, every occupation in the machine tool industry requires use of measurement and math skills every day. Successful machining professionals must understand measurement systems with both English and metric units. They must also become proficient in several areas of math, including fractional, decimal operations, English, metric conversions, basic algebra, geometry, and trigonometry. This unit is meant to be an overview and describes English and metric measurement and gives some examples of the basic math principles and types of operations typically used in the machining field. Later in the text, specific applications of these principles and operations will be explored. In the book here, it gives you another book that if you need help, underneath note, an excellent resource for an in-depth and more comprehensive study of these and your math topics in specific machining context is Mathematics for Machine Technology by Robert Smith and John Peterson. We're not going to go into that book. Feel free to get it on your own if you would like. The Machinist Handbook would be, if you were to get any extra books, for sure, the two important books that you might want to purchase if you're going to stay in the trades, specifically on machining and welding, would be the Machinist Handbook and the Pipe Fitter's Handbook by Franklin. Okay, there's several different versions of the pipe fitters. They're all fairly good. They're usually about 10 to 20 bucks a piece. There's a lot of trig, math, basic equations, basic fractions in there, as well as the Machinist Handbook is a very thick book, but it covers almost everything. Okay. Moving forward here, we're going to do the introduction to English and metric measurements, demonstrate math principles, explore typical math operations for machining. Reading off the PowerPoint. The English system, it's standard in the United States, fractions and decimals, both common. Most of us are aware of this system. Most of us are even aware of the metric system. However, we're going to break it down, try to give it relevance as we're going through this. The metric systems, or most commonly referred to as SI, okay, used globally, uses decimals and not fractions. A lot of people think that, oh, we're in America, we just use English for the most part. That's not true. Especially with standardization, the ISO standards, the International Standards of Organization, we're seeing a lot more standardization going towards the metric system or the SI system. Okay, you will quite possibly be working on prints that might have been engineered in a different country. You're building the part here, but it may have been, the engineering portion of it may have been somewhere else. It may be spec'd in both English and SI. Okay, so let's move on. You can read through these topics in your book, page 65. We're going to break down into the fractional parts or a whole. The machining inch is often divided into 2, 4, 6, 8, 16ths, 32nds, or 64 parts. So you'll hear them referred to as just that. Either half, quarter, eighth, 16th, 1/32nd, or 1/64th of a part of an inch. Okay? So example here, 5 of 8 parts, 5/8 of an inch, if we're dealing with the inch system. Okay? What if we had 6? If we had 6/8, same thing as if we were to break that back down, 3/4. Okay? A lot of times we're going to start talking about how to break down your fractions, and so forth. Also how to find a decimal system out of those fractions to be on it, so that you can measure down to maybe 1/1000th of an inch. Very important if you're doing fine detailed work, specifically in the machining trades. Okay. Convert improper fractions to mixed numbers and reduce to the lowest terms. Convert fractions to decimals, divide the numerator by the denominator, figure 221. So looking at the book, we are on figure 221 is on page 69. There is a handout or a breakdown of your decimal to inch conversions there. The top of page 69. Okay. 1/64th of an inch. The decimal equivalent is 0.01565. So forth. Familiarize yourself with this. Okay. Do you have to know every portion of it? Absolutely not. You can figure this out with a basic calculator as well. Okay. All right, let us move on to the next page. Okay, so backtracking. Oh, here's the breakdown. Let's finish this PowerPoint up, and then we'll come back and actually do some problems. Okay. Comparing fractions and ordering by size, so largest to smallest, so forth. Adding or subtracting fractions, so half plus 1/4. Let's find a common denominator. In this case, it's a quarter, so we're 2/4 plus 1/4. We now have 3/4. Okay. Multiplying fractions, we'll break this down some, and dividing fractions as well. This is probably the trickiest one, is the dividing fraction portion. The multiplying fractions. Is probably the next difficult topic. Here we're at figure 2.21. You can find it in your book. We just looked at it. Okay. So before we break into this, there are several examples in your book. I am going to follow along. We're going to break these down and walk through them. Okay? Again, this is not a math class, this is a shop math class. We can get a lot more in detail. That is not my intent by any means. My intent is to help you understand. So I'm on page 66, and we're going to break down top left-hand column. We're talking about the numerator and the denominator. So 5-8. So this, the top, is your numerator. Denominator Okay? So this is what we call a fractional term, a partial number. So we get a mixed number. It goes down into it, talking about mixed numbers. So say we have 3 5/8. Okay? All right. So when we have a mixed number like this and we want to break it down into a larger number, let us very simply show you how we do it, how I do it in the trades, and I think it's a simple method. You have can be wrote either way. I'm going to do it this way for simplicity. Multiply, add. Okay? So 8 times 3, a lot of times you can see a dot instead of an X. Okay? So 8 times 3 is 24. If you have issues with this, which some people do, that's fine. 8 plus 8 is 16, plus 8, 24. Okay? So now we've taken 8 times 3 plus 5. So we've got 24 plus 5, 29, eighths. Okay? Real quick, in your book, shows you something different. Tells you it's 28 eighths. Correct? So I want you to work through this real quick. Anytime you run into a problem like this, I want you to prove it yourself. Because I can be wrong, the book can be wrong. There are several factors. There are several times that we're going to make mistakes. And there's mistakes in the book, there's mistakes I'm going to make. And I always prove it. And sometimes I'll do this 3 or 4 different times just to make sure. And I want you to do the same thing. Break it down. If you don't understand it, work through some simple questions. Just make them up. Come talk to us about it, and we'll work through them as well. If you can see what we did, multiply, add, we are at 29 eighths. Your book says 28 eighths. Okay? This is called an improper fraction at this point. All right. So now we just took a mixed number. We broke it down into a improper fraction because the numerator is larger than the denominator. So what if we have it on the exact opposite end? Oops, sorry, I don't need to be holding that. So here in the book it shows you 28 eighths. Okay? Now, when it's taken this way, it has to be the reverse. So how many times does 28 go into, or does 8 go into 28? So we know, just real quick, we can always use a calculator, but sometimes we're not going to have a calculator. So real quick off our math table, we know 8 times 4 is 32, 8 times 3 is 24. So we can automatically go 3, and then we have 4 eighths, 3 and 4 eighths. How many times does 4 go into 8? 3 and 1/2. Okay? At this point, it's also comparable to 3.500. Okay? All right. Let us look at the example here on page 66. I'm just going to pick a couple of them real quick to walk through, make sure we understand them as well. Order these fractions from smallest to largest. Sometimes you're going to see this when you're in a 64th. You're kind of thinking in your head, now, how am I, do I need a drill bit that's larger than 3/8 or smaller than 3/8? Where am I at? Okay? So we have 7 30-seconds, 1/4, 5/8, 37 64ths, and 13 64ths, or 13 16ths. So looking at this, all of our denominators are opposite. However, they're all even numbers, and if we start doing the math, we figure out that they can all go into 64. So, real quick, we know this one is going to stay the same at 37 64ths. Okay? Start with this one. 64 and 32, this is half of 64, so we need to take this and multiply it times 2. So we have 14 64ths. 4, how many times does 4 go into 64? Real quick up here. What if we took 4 multiplied by 16? So we got 16 and 16, so there's 2. That's 32, doubled, 64. So this is also 32. 32 and 32 equals 64. So now we have 1, 2, 3, 4. So this we need to multiply by 16. So we're at 16 64ths. Okay? 8, well if this was 16, then what is this? How many times is 8 go into 64? Off of our math table, I know it's 8 times. However, let's look at this again. Break this down again. We've already got this up here on our piece of paper. So 16 is 8, 8, 8, 8 to 32, 8, 8. Now we have 1, 2, 3, 4, 5, 6, 7, 8. 8, number 8s go into 6 to make the 64. Okay? So 8 times 50, or 8 times 5, I'm sorry, is 40. Times 1. 16 in there, times 4. We know that because of right here. So 4 times this, doing long addition, multiplication again. 4 times 3 is 12, carry the 1, 4, 5, 52 64s. Okay, so real quick, we know this is here. So say we have a drill bit that we know a drill bit is 42 64ths. We're cutting a 5/8 hole. It's not a critical measurement, but we need to be bigger than a 5/8, or at least a 5/8 or bigger, but we don't have a large selection of drill bits. In our box, we find a 42 out of 64ths. Real quick, we can do the math. We now know that it is larger than a 5/8. We could possibly use that drill bit to drill those holes, especially in a fabrication project where the tolerances aren't being held within spec. Okay? All right, that was just a quick comparison of which one is smaller and larger. As you can see, we had all the numbers there in the 64ths. From that point, we could start categorizing smallest to largest. All right, so next, there is an example. Right-hand column. No, I want to go stay down on the bottom section of this book, page 66. Let's go down here and figure out how we find a decimal point. Okay? You divide the numerator by the denominator. So, real quick, just like the book shows, 7 30-seconds, and we want to find it in decimals, thousandths of an inch. Okay? Say we're going to go to 3 places. All right? So very quickly on our calculator here, we're going to go 7 divided by 30. 32 is equal to, so if you see, here's how we do it on a calculator. Just a plain calculator, we don't have to have a fancy one. 7 divided by 32 is equal to 0.21875. So we're going to take it 3 places. Okay? 0.21875, round up. In most cases, we're going to round above 5. So 5. Let me break it down just to make sure. 2, 3, 4, 5, 6, 7, 8, 9. From here, if we are in these numbers, we round down. If we are in these, we round up one number. Okay? So in this case, it's a 7. We're down here. We're going to round up. So now we have 0.219. Okay? If this was a 3, we would round down. We're at 0.218. Okay? All right. You can look through those. I want you to work through some of those on your own. Make sure that you're comfortable with how to take a fraction to a decimal point. And so next one, your next example is on page 67. We're doing fractional addition. Okay? So you have the book there in front of you. However, I'm going to walk through it here on the board to help explain. Some of you might be very comfortable with doing this. Some of you it may have been a while since you've had to do this, and some of you may never have been exposed at all. We're going through it just to make sure we're all on the same page. It never hurts to do something more than once. Okay, so out of the book, we're at 3/8 plus 5/32 plus 7/16 plus 1/4. Okay, so again, we're going to try to find the common denominator. In this case, we know it is 32. Okay, so real quick, put it up here. This one's already at a 32, so let's just put 5 there. Okay, let me try to simplify this. So this one's going to stay the same. So we multiply times 1, 5. Okay, in this case here, 16 goes into 32 times 2, 2 times. So we take 7 times 2, 14. 4 goes